With that, we'll go ahead and get started. A little bit of an agenda up front. We're going to talk about some challenges associated with product development, and then talk about some solution and specific capabilities, and then we'll actually get a little bit into the software and show you what that looks like. So let's get rolling. Challenges. Design decisions are often driven by manufacturing constraints and limitations, right? As engineers and designers, we don't necessarily have all the freedom we want to innovate and to explore different solutions. We always also have to consider manufacturability, and sometimes that's a constraint relative to some of the innovation and new ideas that we might want to try. Additionally, we think about things like cost and lead times that may be affected by tooling and other manufacturing processes. Thinking about things like the jigs and tools and fixtures and those types of things that needed to be added into the product development process. Along with that goes cost and additional effort to create NC toolpaths and other things associated with creating that. What we're showing you on the screen here is just, we'll get into the details of some of that a little bit later on, some of the lattices and things that we can do in the additive manufacturing area of functionality inside Creo. And the idea here is that we're trying to come up with custom products and new ways to develop products and create new and innovative products. Oftentimes, though, that we find that designs can be over-engineered and not necessarily always optimized as well as they could be for their final use due to things like changes to the model, changes to design, so we don't always get the best model that we want or the best product that we want without a lot of extra work and overhead. So PTC's got a pretty broad and diverse set of manufacturing functionality. So we're not going to cover all of those things on the slide, but just to give you sort of a taste of the things that are out there inside the Creo parametric palette of tools, everything from subtractive manufacturing. We see all kinds of different functionality for that. What we're really focusing on is the bottom portion of the slide here with the 3D printing, additive manufacturing, and there's some different new functionality here that you might not have seen before. So strategy, PTC is responding to customers that have expressed the needs here for some way to integrate this additive manufacturing functionality into their design tools. So what we're looking for here is a set of tools that let me lighten the design and come up with creative and innovative new ways to build geometry and create parts. So along with that comes the functionality of the additive manufacturing, and there's things that we're talking about here. We'll show you this both on the screen in Creo and in Lauren's physical example. She's actually printed out a part for me. So things like self-supporting geometries, getting things ready to go for the 3D printer, the slicing, and not only that, but ways that we can create new geometry with lattices and things like that that give us lighter weight parts that still perform as intended using this additive manufacturing functionality. And there's a wide array of 3D printers that we can communicate with from Creo Parametric directly. So an example of a workflow, so there's both the subtractive and additive manufacturing that's sort of described here on this page. So there's generative design as well, and I think we've done other webinars on that, but if you've got questions on what that is, we're certainly happy to talk about that too. The generative design basically says I've got an envelope for a particular part, and I know the situation that part's going to be in. I know the load that it's going to see, and I know how it's going to be held in place and constrained. And then I also might consider things like the manufacturing process. Is that something that's going to be 3D printed? Is it something that's going to be a cast model? Is it going to be an extruded model? Something like that. You can choose different options for how you're going to actually manufacture that. And then the generative design tool can take all of that information and sort of optimize that design for you, and then give you a resulting output that then you can either take out to a machine tool or you can take to 3D printers and fabricate the parts that way. So really, there's a couple of different branches on this, and what we're going to focus on here is maybe more along the lines of this biomimicry or bionic type shapes that have the lattices and whatnot inside the part that can then be 3D printed. So probably not going to create that using your traditional subtractive manufacturing technology and functionality. But that's really where the additive manufacturing comes in, utilizing the 3D printing capabilities to give you the internal lattices with the different materials to ultimately create the part that satisfies your design criteria and allows you to do innovative and creative new designs. So what that really boils down to is the additive manufacturing extension from PTC. So what is this? Well, it's an add-on extension, as I mentioned, that gives me automated lattice creation and optimization, as well as the printer tray setup, things like nesting of multiple parts on the table and optimization for orientation on the table and those types of things. So it gives me a fast capability to do either 2.5D or 3D lattice structures. We'll show you what that looks like in the software here in just a bit. Gives me the ability to have parametric control over the geometry. Right, so here's an example of some 2.5D, 3D lattice structures internal to a part. And we've got different parameters and different types of geometry that we can create inside the volume of that part. And this is going to be integrated in Creo Parametrics, so that means you have access to simulation tools. So things like Creo Simulate Live, etc., Creo Ansys can be used to do your analysis on the model to make sure that you're actually getting the performance that you intend based on your new creative lattice structure design. Additionally, we talked about the printer tray optimization. So once I've got the part designed, I can take that out to the 3D printer, but maybe I want to print multiple different parts simultaneously or make a kit of parts. Well, I can do that with the printer tray optimization and help me figure out not just the placement of parts relative to each other, but also the optimal orientation so that you know how the part is actually going to be built up on the table, and it can create the supports required to actually build that part on the tray. So then we think in terms of connectivity, right? So you can print directly from Creo. So there's capability and connectivity for roughly 70 to 80% of the metal printers that are on the market right now. So Materialize, GrabCAD, Print, 3D Sprint are options there. And there's the integrated printer manager, right? That's directly inside Creo. So then you just basically, once your printer's connected to your network, so you can see it from Creo, it's just like printing with Windows Print Manager, right? You select the printer that you'd like to go to, and then it goes ahead and sets up the process for you to connect to that printer and generate the output. Additionally, we talk about the tray configuration here. So there's the process of starting off with the model, optimizing the design, adding the lattices, etc., and then taking that out to the printer. Well, it needs to be sliced, and those things need to be accounted for as well. So there's tools that do that inside Creo that let you go directly from your 3D model in CAD out to the 3D printer. And as I mentioned before, automatic generation of support structures. So there's a difference in printing, whether you're printing in metal, obviously, or printing in some other plastic or some other type of material. You might need different types of support structures that go along with that. And so there's, again, capabilities in the additive manufacturing tool that allow me to create those different types of structures, supporting structures, to hold the part while it's actually being printed up on the table. Additionally, there's another extension that allows me to do the simulation of the printing. So we can look at things like if you're doing metal printing, you need to, it's very much like welding, and you need to worry about, consider, not necessarily worry, but consider the heat that's being put into the part as you're fabricating it. And so you can use that simulation tool to account for things like warping and deformation of the part as it's actually being printed. So that functionality is there. Won't necessarily talk about that today, but if you have further questions on the actual metal printing, track us down, give me a call. We'll be happy to discuss that further as far as the simulation of the 3D printing in metal. So with that, I'm going to go ahead and drop out of presentation mode here, and we'll go ahead and take a look at a part. So in this case, this is a part that I've got a lattice sort of set up and started, but how do I do that, right? So in the engineering portion of things here, we're going to have the ability to come back in and create a lattice, right? So this is a functionality that'll be enabled for me with this additive manufacturing inside Creo. And I've already got that lattice created, so let's just kind of dive in and take a look at the creation of that and some of the options that we have. I've got a cross section here in the model we can take a look at, and I've just sort of sliced away this corner so we can see the area inside and what that lattice might look like. So let's go back and edit the definition of that. So So the first thing you need to do is to specify the region or volume of the part that you want to create the lattice in. And so we've done that. We've got collected the internal surfaces of the model that are shown there in green. And it's just you can use seed and boundary, or you can use any method you'd like there to select the surfaces of the volume that you want to sort of contain and create the lattice within. And then from there, you've got different options, right? So here, I'll close the lattice region, right? And then we'll say we've got different options. I can create beams, which is where we are now, or I could create 2.5D type options, or I can use formula driven. And we'll show all of those different options to give you an idea about what that looks like. So if we start off with the beam direction, we'll just use the Z direction as far as orientation, but you can change the orientation of that little lattice inside that volume. And of course, you got the little drag handles here that you can use to sort of manipulate that in size and scale that lattice that you have set up inside the part. Right, so it gives me sort of a preview of where that lattice is going to start. You've got other options for controlling the size of the geometry that gets created inside there. So the diameter of the beams and the little nodes at the interconnecting locations for the beams, you can change those sizes as well. If you go ahead and preview that to get an idea of what that lattice is going to look like, you can go ahead and do that. And I've got this cut is actually created after the lattice is created there, so that preview isn't necessarily going to show. But we'll tap through some different options here to kind of show you what that looks like. So if we go back here and change the beams, we'll go back and change that to 2.5D type option. So here I've got triangular, prismatic, hexagonal, and octagonal shapes for the lattice inside there. Additionally, I've got control for the size of that cell and a skew angle. So if I wanted to rotate that, I can certainly do that. Right. So again, if I want to change the wall thickness, so what we're talking about now is the actual thickness of the wall of the cell. So if we maybe doubled that and made that be 0.4, we'll have a little bit thicker wall. I can have a radius that I add inside the different areas of that. So the internal radius and the external radius. If I'd like to add drain holes inside, and I can change the size of those drain holes as well. So I've got a lot of pretty easy control over granular features for the inside of that lattice that I'm creating. So if I wanted to do that, we change the orientation here and actually have that be maybe in the Y direction here. And then if I go ahead and accept that, that'll create a new lattice then that gives me a completely different set of geometry. So again, I could send that out to the 3D printer and show what that would look like from there. So that's a couple of different lattice types. Let's go back and look at a couple of different options here. If we change that from the 2.5D, if we take a look at the formula driven. So this would be, say for example, if I'm looking for a more organic sort of fill for the lattice internal to the part. Go ahead and do that. I'll just accept that here. We've got different options for that, but what I want to do is create that and then put a section through the part so you can actually see what that looks like. And if we go ahead and we'll just create a quick little section here. X direction. Right, so you can see internal to the part then that it creates that sort of organic sort of shape that allows me to optimize it and remove the material from inside the part, but yet still have structure inside there for strength. So it allows me to lighten that part and sort of change the net result of that. You can see that dynamically dragging through the section what that particular lattice setup is going to look like. So again, a couple different options for you as far as the different types of lattice that you can create. From there, if I wanted to print that out, let's go ahead and just turn off that section for right now. If I wanted to send that out to the 3D printer, I've got a cut in there as well that will show up when Lauren shows you the part. Pretty simple setup, right? I would just go ahead and say, hey, let's go ahead and set that up to the printer. I'm going to prepare this model for printing. Right, and then it gives me an example of what the tray is going to look like. From there, here's where I would have my printer manager. So I've got different printers that would be connected, and I can select that just like I would a printer on the network somewhere. If I wanted to assemble components on the tray, I can do that, right? Assemble multiple different components, just like you would assemble any other part in any other assembly inside Creo if you wanted. You can go ahead and do that. And then the other thing, if you want to just go ahead and arrange that on the tray, it's going to go ahead and place that on the tray for you. And there's an analysis option that allows you to go ahead and look at, based on a reference in your part, figure out what the optimal angle for orientation on the table is going to be. And it'll actually reorient the part for you on the tray and then put it in and build it in along with the supports that go along with that. So that would be what it looks like to arrange the parts. If you wanted to scale that part up or down, you can do that too. And then generating the support, probably not going to need a lot of support external to this part, but if you oriented it differently, you certainly would need support, and you can generate the support here by just simply selecting that, and it'll go ahead and analyze that for you and then figure out, well, what do you need to do as far as supports to hold that in place. And you can see there that it's built the supports in the model to build that on the tray. And then when you're finally ready to go, you would do preview for 3D printing, and that'll do all the slicing for you, and then get that ready to save as a file that you would then send to the printer and generate the part. So that's an example of what the process would look like. From there, I would go ahead and hand it over to Lauren, and she can show you what that would look like when we printed that part on the Formlabs 3D printer.
Hi everyone, my name is Lauren Adey. I'm the additive manufacturing specialist here at EAC, and I help our customers bring 3D printing solutions in-house to save time and money over outsourcing and 3D printing service bureaus. So welcome to our demo suite. Behind me here, I want to show you the printer that we use to print the parts I'm going to show you in just a minute. This is our Form 3. It's a desktop SLA resin-based printer. And it's a great, affordable, and easy to use option to pair with the Creo additive manufacturing extension to, again, bring that process in-house and have complete control over your 3D printing and the parts that you're creating. We all know that it can be timely and costly to send our parts to a service bureau or third-party 3D printer. So I just wanted to show you the part here that I used the Form 3 to print. And this is the part that Todd was showing you guys in the Creo extension demonstration that he just did. And so I actually did a cross section to show you guys the lattice feature in here. And adding lattice structures into a model is a great way to save on print time, as well as the material usage. So you're also saving money there as well. And I just used the standard gray material for this print, but Formlabs has a wide variety of different materials that you can use depending on your application and any functionality needs that you may have. And I actually took the supports right off of this part here, but I wanted to show you what it looks like coming off of the printer. This is the build platform that the part gets taken off of. And you can see the support structures there that are printed to support your part. You can see that. So Formlabs also has a larger format 3D printer right here, the Form 3L, that you can use to print larger parts up to 5 times the build volume of what I just showed you. So things like this big vase here, this big vacuum nozzle. So it's a great way to print any consumer parts or design iterations that you want to run through. And things like these slotted spoons. So yeah, that's kind of what I wanted to show you guys here in the demo